Higgs boson,
चंद्रशेखर लिमिट,
string theory,
न्यूट्रिनोस,
quantum entanglement.
कुछ समझा क्या?
Ever felt bored and confused while reading lengthy physics textbooks or articles?
Yeah, on God, bro.
I'm Arnav,
And I'm Pratham.
and welcome to Quark Talk, where we decode all the complexities and simplify these intricate concepts in physics.
They may have seemed too complex to understand until now.
So, there's this place in the United States of America, and it's open to the public for just 2 days in a year. Pratham, why don't you take a guess at what it is?
Is it Area 51?
Nope.
Wait. Is it Donald Trump's underground bunker?
Nah.
Okay. I think I know.
Okay.
I think it's Elon Musk's private airport.
Yeah, no. Yeah, okay, so that was close, but physically, not actually, it's the Trinity bomb test site, where on 16th July, 1945, at exactly 5:29 and 45 seconds and 200 milliseconds.
Okay. Basically like 5:30 in the morning, which is when I get up.
Yeah, I know. So that was basically where the world's first nuclear bomb was exploded, and that was called Trinity.
Yeah, we spoke about this in our Oppenheimer special.
Yeah.
Now, the test was top secret and the general public want to know about this.
Wait. How do you hide such a large nuclear explosion?
Yeah, let me break it to you. They didn't really do a good job for that. So, but I will. And I will make America great again.
Okay. Don't already shoot at the stars. You aren't the president just yet.
Please, okay? I just got a bit carried away.
Okay. Well, at the time, a newspaper published a statement and it claimed that the bomb blast was just a large but accidental conventional explosion.
Okay.
But it wasn't just the general public who were kept in the dark about this. The governor of New Mexico, for example, wasn't even aware that Trinity was a nuclear test until after Hiroshima was bombed.
Oof.
Even then, the details about the blast were scarce.
Now, it's my turn to ask you, okay?
Okay.
So, here it goes. Are you aware of what Kodak is?
Well, Kodak? I've heard of it, but I'm not sure what it is.
Well, when you were younger and you went to get your picture taken or your photo taken,
Okay.
at the back of those pictures, you would see Kodak like written diagonally across those, like in lines.
Oh, yeah. Okay. Now, Dadaji, please get back to the point.
Oh, okay. So, Kodak was this film company in New York and it actually found out about the nuclear test and kind of by mistake though. So, it all started with some defective X ray film. So, Kodak found that when they developed unused film, it showed tens or even hundreds of little dark spots. And the film had been exposed to radiation even though it had never even been taken out of its packaging.
Interesting. But this wasn't actually a new problem. During World War II, in fact, radium was used extensively to make glow in the dark dials, flight instruments, and watches. And it glows because it's radioactive and it gives off alpha particles. And some of it ended up on the paper and the cardboard at these factories.
Okay.
Now, supplies were low, and the leftover products were salvaged and recycled. So, this led to small amounts of radium ending up in the general paper supply.
Yeah. And when this paper was used to package up Kodak film, radiation from radium would expose the film before it was ever used.
Oh, that's where we got it from.
Yeah. So this had become such a big problem that Kodak even altered their supply chain and they carefully selected just a few paper mills where they could strictly control the raw materials and thereby avoid.
Contamination. Smart.
Correct. So one of the mills in Indiana was operating perfectly until a batch manufactured on 6th August 1945 started to cause spots to appear on X-ray film.
So, Julian Webb, just a scientist at Kodak, was tasked with solving this problem. He punched out the little holes of straw board behind where the film had been exposed, and then he measured the alpha particles coming off of it. The level wasn't like that much higher than the background, so he ruled out radium and all the naturally occurring isotopes. So when he measured beta on the other hand, he found a lot of activity. This matched what he saw in the film because the radiation had penetrated several layers.
Okay.
But alpha can't do that, but beta can. Okay. So over a period of couple of months, he did some research, did some experiments, and measured the half-life of the radioactive substance. And he found out it was only 30 days.
Yeah, and half-life, just to let you guys know, is basically like an exponential function about the lifetime of a group of atoms. So let's say if it's 30 days, then every 30 days the sample of atoms will reduce by half. And this is linked to probability as well.
So if you have like, let's say like a random amount of 10,000 atoms,
Yeah,
and if you go wait for 30 days, I'll get reduced to 5,000. Another 30 days,
2500.
exactly, and so on.
Yeah. So, this half life, combined with the energy of the beta particles, led Webb to conclude that the radioactive contaminant was mostly cerium 141, an isotope that would only have come from a nuclear fission explosion.
What's more, the same contaminant appeared in a paper form in another one of Kodak's mills. This one was hundreds of kilometers away in Iowa. So wait, how did cerium 141 end up in that starboard? When that first atomic bomb exploded in the New Mexico desert, the plutonium core that we talked about earlier,
Yeah.
it underwent a fission chain reaction, and the plutonium nuclei ripped into two. And this released even more energy and more neutrons to continue the chain reaction, which is basically the multiplication factor K.
Yeah, we spoke about that in the Oppenheimer episode.
Exactly. This is like very similar. But fission obviously is a messy process. It doesn't always split the nucleus into the same products. Instead, there are hundreds of them being produced at the same time, and practically all of them are radioactive. And they're carried up in the atmosphere, usually to the stratosphere, which is the second layer. But the mushroom cloud is dispersed sooner or later
Yeah.
through the air currents, whichever way the wind blows.
Yeah. And in this case, they traveled literally more than 1,000 kilometers, ending up over Iowa and Indiana. The rain would have captured some of these radioactive particles, causing them to fall out of the sky, which also gives us the term radioactive fallout, as we know.
Ooh, yeah.
Yeah. So, this radioactive material ended up in rivers like the ones that run beside the two Kodak paper mills, and they use river water to make their paper, right? So that's how cerium 141 ended up fogging Kodak's X-ray film and exposing the US's nuclear secret.
Boom. Mind blown. You want more? Here we go.
Okay.
News of Kodak's detection made it back to scientists at Los Alamos, who were intrigued and wanted to know more. Plot twist: Julian Webb was part of the Manhattan Project at Berkeley and Oak Ridge,
Oh.
and he was literally the one who had used electromagnetic techniques to separate uranium isotopes.
Okay.
Now, although Webb completed his experiments by the end of 1945, he only published them in Physical Review in 1949.
He obviously recognized just how sensitive his findings were.
Exactly.
Yeah. And because these nuclear bombs are being tested, which to some extent contaminate the atmosphere, Kodak was clear that they needed to protect some of their film. They installed air samplers to monitor for fallout in the air intakes of their buildings. And meanwhile, the US government was aware that they needed to carefully consider where to test these nuclear bombs. What they wanted was a site closer to their laboratories and military bases for air support, and obviously somewhere in the continental United States.
But where?
Let me tell you. So, it was recommended by many that for these tests to be conducted, they had to be conducted at least 150 miles away from civilian populations, of course, for safety reasons.
True.
But the site selection committee decided a location on the east coast would be best, because otherwise the westerly winds across the US would spread the fallout across the country.
So they literally did the opposite and they chose Nevada,
Of
almost
course.
as far west as you can go. And it's just 100 miles from Las Vegas.
Great decision.
Yeah. The final reason that they said was it was closer to weapons labs so it could accelerate the development. So they continued to test the bombs, and Kodak actually even threatened to sue them because like the US government did a considerable amount of damage to their products from those Nevada tests or from any other atomic energy tests.
Oh my god.
But instead of a lawsuit, somehow they came to an agreement, and the Atomic Energy Commission would give Kodak and actually the entire photographic industry, they would give them advance warning about upcoming tests and where the fallout was likely to end using very fancy meteorological models.
Okay.
And in return, the company agreed to keep quiet about the fallout.
So, from 1951 until 1963, the US conducted 100 above ground nuclear tests in Nevada.
That's a lot.
Yeah. The resulting mixture of radioactive nuclei was blown, as predicted, across most of the country. And when these atoms fell on agricultural land, they were eaten up by livestock or taken up in crops, and basically they became part of our food supply. Radioactive iodine 131, eaten by cows, is passed on to humans through their milk, and it's basically problematic because iodine is concentrated by the body in the thyroid gland.
And who drinks the most milk? Children. with small developing thyroid glands. Now, please don't stop drinking milk. These tests has happened decades ago.
Yeah.
So,
It's estimated that the nuclear tests basically led to thousands of extra cases of thyroid cancer. And the Atomic Energy Commission wasn't too worried about iodine 131 because it has a radioactive half life of only 8 days and it decays very, very quickly.
so they were actually more concerned about strontium 90, which has a half life of almost 30 years.
Oh.
Plus, it behaves biochemically like calcium. So, when ingested, it ends up in our teeth and bones. As it emits ionizing beta radiation, it can cause bone cancer, cancer in the surrounding tissues, or leukemia.
Yeah, I remember studying that in bio.
Same. And this radioactive decay almost certainly increased the rates of cancer and other diseases in the US population. But it was like borne out by studies showing correlations, not necessarily causations.
SAT.
Yes, between the rates of disease and the radioactive isotope uptake. So it wasn't really sure, but it was very positive correlation.
Yeah. So the peak was in 1964, just after the partial nuclear test ban treaty was signed in 1963. It banned nuclear tests in the atmosphere, underwater, and in outer space, leaving only underground tests.
Oof.
A central aim of this treaty was to address the growing public concern over the scale of nuclear tests and basically the resulting radioactive fallout.
So almost 50 years later, in 1997, the agreement with Kodak was sharply criticized. And this was because the government had warned the entire photography industry and they had given them maps and the forecasts of those contaminations that were possible. But they completely ignored the dairy farmers and the parents of children.
Yeah, I know. And it's so surprising. A senator even said the government protected rolls of film, but not the lives of our kids.
Now, they weren't that bad also. The main problem was at that time, there wasn't much information about it. They didn't know about the biological effects of the radioactive fallout. Cancers took years or even decades to appear, and fallout models predicted a more uniform and therefore less concentrated spread of contaminants.
What is certain is that 1945 marked the start of a new era. No radioactive fallout before then, and then lots after it. This had unforeseen and unexpected consequences.
True.
Some good and some really bad, obviously.
Yeah.
You can use this to detect wine forgeries, art forgeries, and also to determine the age of a skeleton and how long ago that person died. Given it's in the past 75 years from now on. So, this technique has been very useful in many cases where there were no reliable methods of estimating the year of death if it was within the last 50 years, right? Like, this is very useful for historians and all.
So that method works because while we are alive, we're ingesting strontium 90 and it stops when we die. So to this day, we all have some of it in our bones, although obviously at lower levels, because it's been around two half lives
Yeah.
since the peak of radioactive contamination. So 3/4 of it has been decayed,
Yeah.
and the rest of it has dispersed throughout the environment.
And because of that, these days, it's no longer much of a health concern. Still, it is there inside every one of us. We are of this modern age. In our bones are the little atomic fragments of atomic bombs that exploded decades ago. Isn't that amazing?
Yes, it is.